Hello, hello. First things first, let's just make sure you can hear me. So, if you can hear me, please just put in the chat that you can hear me. For anyone that hasn't done this before, there's a chat window on the right-hand side of the stream video. Please use it. It makes it a lot easier to make sure you're following along and makes it a little bit more interesting for me. So I'll just wait and make sure that everyone can hear me, that I'm not just talking to myself, or if I need to turn the volume up or volume down, etc. It's all good. Can you hear me? Just write in the chat. You can hear me, please. Hear me? All good. Can everyone else hear me? Please just put something in the chat if you're here, so I can make sure that there's a couple of people here before we start. Cool. All right, so let's get started with this. So this is a help session for assignment 3, which is due next Sunday. This assignment is your final assignment for PES or CES. And this assignment focuses around images and what we've been doing in the labs for the last couple of weeks. So let's go through it one by one. So to start off with, as I said, we're going to use images. Specifically, we're going to use bitmaps. Okay, that's important. So every image that we use will have the extension .bmp. Now, you cannot see the images on Unix. You will need to open them up in Windows or Mac OS in some kind of image editor or image viewer. Now, you're welcome to use your own images. There's only one little caveat with that. Basically, firstly, you need to save them as a 24-bit bitmap. And you'll see that option in Paint or Photoshop or whatever you use to save your image. And another thing is that the width of the image times 3 must be divisible by 4. So there shouldn't be any remainders. This is just because we're avoiding padding in this problem. So if you do want to try your own images, that's the way to make sure that your images will work. The images provided with you all fit this rule, so you don't have to worry about that. We then have the problem. So we're going to create a program that does a couple of different operations on images. So the first one basically just loads an image and then saves it again. And so this creates a copy of the image, and just make sure before you start trying to do things with the image, you can actually load it up and save it. The next one is remove a channel. Okay, so you've got a image, and you've got the red, green, and blue components of the image, and you can remove all the red components, so there'll be no red in the image, or you could remove all the blue components or all the green components. The next one is quantize, and this basically reduces the number of colors in an image. So this means that with your image, there'll be lots of different colors. So for example, for reds, there'll be 255 reds, but you reduce the number of colors and you'll see that you might only get 2 reds for a particular type of quantization. Invert, so just inverting the colors and then flipping the image horizontally. The thing to note is that You do need to follow the steps. This isn't the ideal solution. It's one to test your knowledge on various topics in the subject. Okay, so even though you might come up with something that might solve the problem, you need to do it the way specified, as it's designed to test your understanding of what we've covered in the class. All right, the first things first, you need to include standard IO, the standard lib, and the string.h files. These need to be included. You can't use anything outside of this. As you can see, we will be doing some string operations, so you do need to read the lectures for that. You're then going to add a macro, which is the max file name size. Don't do something silly like put the equality operator in here. If you do that, it won't work. It will replace anywhere it says max file name size with this symbol. Okay, and it won't compile. So make sure you don't have that when using macros. It's a common mistake that a lot of people make, and a common mistake that was made in the assignment 2, but most people fixed it up before submitting. We then have a huge amount of function prototypes compared to any lab or assignment we've done so far. The first 5 are very simple prototypes. You can see that they return nothing and they accept nothing. So they're just going to be a simple operation that'll probably call other functions that will do something useful and will accept information. We then have our load image and save image, which will do what it implies. Note that the load image accepts a pointer where the save image doesn't. Okay, so remember that when you've got a pointer to a struct, you do need to dereference that pointer as to access the elements within it, the members within it. And a shorthand way of doing that is the little arrow symbol. If you've actually got the struct itself, then to access the members within it, we just use the dot. Okay. We also have a function for freeing memory. Okay. A lot of people forgot to free memory in the second assignment. It is an important step. We are going to dynamically allocate memory here on the heap. And so you need to make sure that you free the memory correctly. We've then got our operations that we mentioned earlier. So we have inverting the pixels, okay, and that accepts pixels. We then have flipping horizontal. We have quantize, and we have remove red, green, or blue, and that's for removing the channels. All of these are described below. You cannot change the naming, and you cannot change the type for this assignment. Okay, so don't make your own, and you do need to use them. Okay, so don't try and get away with not using them. Some people did that in assignment 2. We then have 2 structs. We have the struct called pixel, and we have the struct called RGB image. Note that struct pixel is declared first, defined first, sorry, is defined first because it's used in the second struct, which is struct RGB image. The struct pixel, so if we take an image, okay, will tell us information about a single pixel, where the struct RGB image will tell us information about the whole image. Okay, and we'll have a look at that in detail when we get there. I don't know why I'm rubbing this out. All right. Function, main. First thing, as you've done every single time, print out your name and student number and the assignment number with 2 stars. Okay, so there's 2 stars beforehand, there's 2 stars after. Don't forget those stars, they are important. Next thing, create a menu as shown. Okay, so you've got a menu. Okay, this is your menu. It's 1, 2, 3, 4, 5, and -1 for quit. Basically, this is all just printf statements. Okay, so you can just have printf, 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 a bunch of printfs for each line. You can combine them, but it does look nicer and easier to read if you do a single printf for each line here. Okay, so we're going to have a bunch of printfs. There's no variables that we need to print, so there shouldn't be any additional arguments other than the string, and there shouldn't be any format specifiers. Now, if an invalid integer is entered, the menu appears again with no prompt. Okay, so in this assignment, we are not testing if you can capture mistakes. You've all shown that you could do that in the first and second assignment, and we don't want extra code that we don't need to mark. So there is no prompt to say you entered the incorrect answer. Please try again. We don't want this time, so please don't do it. You can assume that the user always enters an integer. They're never ever going to enter a string. All right. Now, if the user selects a valid entry, 1 to 5, then the appropriate function should be called. After the function's call is finished, the menu should be displayed again. The program should end when the user enters a -1. So if we have a look at this, we've got a case that we need to loop. Okay? And we have 3 options for our loops. We have a do while, a while, or a for loop. So in the chat, which one do you think is the most appropriate for this problem? Just make this a little smaller. Oops. Oh, I mean that. Move that a little bit. Excellent, excellent work. So a do while is the most appropriate here because we have to print the menu at least once. Okay, so we're going to do this. Then we're going to get the user's input. So we could either, we said that it's an integer, so we're going to need scanf. Okay. Now you need a variable for that, maybe something called choice. You do need to declare it outside of this do while loop if you are going to use that variable when you use the while. So maybe I'll just have a variable called choice. Now, don't make the mistake of making this unsigned because you'll never exit the loop if they enter a -1. Okay, so it needs to be signed. All right, so we've got a loop, we print out the menu, we get the user's input, and then based on that input, we make a decision. Okay, so we're going to have a bunch of ifs. If this, we call one function, else if, we call another function, else if, we call another function, and we should have a couple more of those. So we have 1, 2, 3, 4, 5. We're going to have 5 else ifs. Now we don't have an else here because there are other things that the user could enter, such as invalid things, and we're not going to tell the user that they entered something invalid. It's just going to print again. Now, just a trick here, we can start calling the functions. So these are our functions here. Okay, so save image copy, for example. Now, if you haven't written that function yet, what you can do is below main, create all your functions. Okay. And all you do inside them is just put a printf and just write not yet implemented. And it'll tell you that you actually entered there. Okay. And this part does work. It's just not implemented yet. And it means that you won't get errors saying that this function doesn't exist. Okay, so that's a little trick you can do, is just write all your functions and just put a printf not yet implemented so that you've got them there. And you also can clearly see which ones you haven't actually done yet. Okay, and it means that you won't forget any. Okay, so we've got our do while loop. We print the menu, we scan the user's input, we check if it's one of these 5, and if it's not, then we don't print anything. And then we have the while at the end. And that's going to be while some value is not equal to -1. Okay? And then we can just return 0 at the end of main. So this here is fairly simple. It's nothing new. It's very basic. And this means that you can test this pretty early on. And I think most of you understand this given the answers in the chat. All right. So that's your main. Okay. Make sure that works completely first. Try a whole heap of values and do make sure it works. I'm just going to move that somewhere so that I've got a bit of room. Oops. Probably won't need it, but I won't move. All right. So now we've done that, we can start looking at the load image function, which is the one that's going to cause the most problems. So let me just that there, and now I've lost the chat. All right, so we've got a function called load image, and it accepts a pointer to a struct. So it means that before we've called this, we do have a struct RGB image. So what I'm going to do is let me just get up the definition of this struct. Okay. So let's draw this out. So somewhere up, wrong thing, sorry. All right. So somewhere else, okay, we have a struct. Okay. So let's draw this. Okay. And I don't know what the name is. I'm not going to worry about that. But it's a struct RGB image. Okay, and it has some name. I don't know what it is because it's in another function. And it has a couple of members. So the first one is going to be a pointer to the file name. Okay. So that's just going to be a string. Okay, and this is called file name. Okay. So we got a file name which points to, should draw the pointer correctly, the start of a string. Okay. Remember that when you see these square braces, we're talking about a pointer. Okay. So we've got file name to start with. Then After that, we've got 3 ints. Okay, int, int. And we've got height, width, size. That hasn't changed, I don't think, since I wrote this. Yep, correct. And then the last one is a pointer. I might make this a little bigger, because this one's kind of important for what we're doing. The other ones are quite simple. All right, so we're going to have a pointer here, and this pointer, probably make it a little bigger. I'll close it off once I've written it, is of type struct pixel star star. Okay, and its name is pixels. Okay, so this is also a pointer. Okay, at the moment we don't know where it's pointing. Okay, we don't know what the size is, we don't know what the width is, we don't know what the height is, and we don't actually know what the file name is at the moment. All right, so we have that, and then in our actual function, which is the load function, oops, I'll see that. So in our load image function, we have one variable at the moment, which is called image pointer. Yeah, and it's a struct RGB image star, and it just points at this struct. Okay, so we're inside this function. All we have access to is this pointer, but we know that it points to a valid struct. All right. So first things first is that we have to ask the user for a valid for a file name. Now, in the last lab, we did exactly this. Okay, so we asked the user for a valid file name. The only difference here is that last lab we included the extension, where here we're not going to include the extension. Okay, so make sure you're clear about that and understand that, because in this, we're going to add the extension ourselves. Okay, so we're in our function. I'm going to run out of room really, really quickly. So we're in our function. We ask the user for something, okay, and we print it to the screen. Now, we don't actually need to create somewhere to store the file name, because we've already got somewhere to store the file name up here. Okay, so I'll take you through this one, and then you should be able to do the other ones yourself. So we're going to use scanf. Okay, we're getting a file name, so we're going to use CentS. And where I'd like to store it, okay, is right here. Okay, so remember that we want a string. This is a string. Okay, so I'd like to store it right here. So to get there, I need to dereference this image pointer, and then I need to specify the member, which is file name. So I can do this quite clearly here, keeping in mind that this is already a pointer. Okay, so I don't need to specify its address. So here, what I'm going to do is I'm just going to write image pointer. I'm going to use the little arrow, okay, because I need to dereference this. And then I can just use file name. And that means that now this file name, let's say my file's called something simple. Let's what's a good file name? My file name's going to be img. So I've got img, and don't forget that there's a null terminated there as well. Okay. So we've got our file name. Okay. It doesn't have an extension. Okay. And this is important because we're going to edit this. Okay. Now, after that, we're going to create a copy of the file name. So if we're going to create a copy, then we do need to actually create space to store the copy. Now, we just create a copy using the same type. So I might just call it file name with an extension. And what goes here, you should be able to work out, okay, based on the macro. Okay, so some value needs to go here. Now, we're going to use the function string copy. Okay. We don't care about what it returns, but it accepts 2 arguments. Okay. This is the destination. Okay. And this is the source. Okay. So what that basically means, if I have 2 storage spaces and one has a value in it, this is the source, this is the destination. Okay. And so whatever's here will be copied into here. So my source would be my image pointer, file name, and my destination would be my new one. Okay, so that gives me a copy of this. Okay, and then I'm going to use string cat to add the extension. Now, string cat, if I've got a string, say hello, and I need to add something after that, then string cat will allow me to add something after it. So, for example, I want to add Bob after it. Okay, so it allows me to edit my strings. So basically, for string cat, this is the original string. Okay, and this is what I want to add to it. Okay, and I want to add an extension, so I can add .bmp here, and this string is going to be my copy because I don't want the extension to be up here. Okay, so this is going to be my copy here. All right, so there's string cat and string copy, and then you can do what you've done this week with the file pointer. Okay, you can just call it FP, you can call it whatever you like, and then you can use your fopen to open the file. Okay, I don't need to show that. All right, so you can open the file here. Now, you do need to check if the file cannot be opened. Okay, and you've done that this week. Okay, so you need to check if the file can be opened, and basically, if it can't be opened, you do need to return a 1. Okay, and that's important because the calling function actually needs to deal with this. Okay, so we've been doing that anyway, but we haven't dealt with that one. But we are going to deal with it in this program. Yes, there is a prompt. Its file cannot be opened. Okay, so there's 2 steps. If the file cannot be opened for any reason, print to the screen, file cannot be opened, and then return 1. I like that you retracted your message. All right. We're then going to use a new function here. So I'm actually going to remove all this stuff. Yeah, I'll remove it now. I might just move it. I cut that. And move that over there for now. I don't want this. All right. So once we've got this file open, don't want that. All right. I need something else. A second. What I need. All right. So if we have a binary file, okay, and so in the string copy, the dot bitmap gets added. Okay. So you have to add the extension to it. All right. So let's say we've got a file. Okay. Now this file doesn't have formatted data. It doesn't have like ASCII strings and nice numbers and things like that. It is binary data. So let's just say we've got, I'm just going to write it as bytes. So I'm just going to write byte, 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 byte. These aren't Bs, it's just a byte of data. Okay. If you have a look at the image file, maybe I'll do that. I got my, where's my hex editor? I might do that a little later. Okay, so we've got a bunch of bytes of data in the file, and once we've opened the file, our file pointer will be pointing right here. Okay, so it'll be pointing at the start. Now we can't use fscanf for these files because there's not much data that we can actually read using fscanf. And so we're going to be using a lot of fread. Okay. So we want to skip the first 2 bytes. Now, there's a couple of ways we could do this. We could just do 2 reads and just ignore what we read. But there is a better way, and this is fseek. Okay. So fseek accepts 3 arguments. And the first one is just the file pointer. Okay, so we can just write file pointer. The next one is how many bytes we want to actually move across. So in our case, we want to move 2. Now, the last one basically says from where. So we've got a couple of options. We've got seek set. Okay, there's an underscore there. We've got seek current, which is seek CUR. And we've got seek end. Okay, this number can be negative. So what this says is that seek set will move 2 bytes. So it'll move the file pointer 2 bytes from the beginning of the file. Seek current will move the file pointer 2 bytes from where it currently is. And seek end will move the file pointer 2 bytes from the end. Now that would be bad because we don't want to go past the end. Okay, so for seek end, you only really want negatives. For this program, we are only going to use seek current. Okay, we don't need the other 2. Okay, but it is a good way to get back to the start if you ever need. Okay, so what this will do is it'll just move the file pointer to here. And basically the reason we're doing this is because we don't actually care what's here. Okay, so we're just going to skip it. Okay, so we're going to skip the first 2 bytes using fseek. Okay, so if you ever need to skip any bytes, you can use this function and you can just change this value to skip whatever bytes you want. All right. Next, you're going to read the size of the file by reading the next 4 bytes and store appropriately using fread. Okay. So basically here, I've given it to you. Okay. And what this says is where I'd like to store it. Okay. So I'd like to store it at size. So we've got image pointer. We dereference that and get to size. But because this is an fread, I need to give the memory address, not the value. So I give the address of this location. So I'm saying to the function, I would like to store the value here. Okay. I then specify the length. Okay. So it's going to be 4 bytes long. That's how much I want to read. Now, the 1 here is for arrays. So if you had a size array, then you could put another number there and get a whole bunch of numbers at the same time. But our variable isn't an array. Okay, it's just a single int. So it's just going to be 1. And same with height and width. They're not arrays. So they're just going to be 1 as well when we use this. And we've just got our file pointer. Now, I've called it FP here. I've called it file pointer here. You might even have a different name. Okay, so I give you the code there, but I'm expecting you can work out my variable names and compare them to your own. All right, so after doing that, we've read this, and our file pointer would have moved to here. Okay, and we'll have some size in here. Let's say it's 32. It's not going to be 32. It's not going to be that small, but it's a good example. Then we skip the next 12 bytes. We know how to do that. Okay, so we're going to use our fseek again. Okay, and you can do that. Then you're going to read the width of the image. Okay, so pretty much just do this step again, but instead of size, it's going to be the width. And we're going to say our width is 2. And then we read the height, and we're going to say our height is 3. Okay, actually, I might make it 3 and 3. Yeah, we'll do 3 and 3. That'll be nice. All right. Then skip the next 28 bytes. Okay. Once again, you can use fseek to do that. All right. Does that make sense up to that point? Oh. What I'm going to do is I'm going to get rid of all this stuff. All right. Cool. Cool. All right. Now we're going to do probably the hardest part. What I'll do, well, what's the best way to do this without giving all the information away? That shouldn't really matter. All right. So now we need to create a 2-dimensional array. Okay. So if this wasn't dynamically allocated, we could just write, so let's say we had an int, we could just write, I don't know, 3 and 2. Okay. But here we want to actually dynamically allocate. Now, do not put n and m in here. You will see that it works, but it may crash because what you've done, and I saw a couple of people do this in the assignment, rather than use malloc, they put an n in here. And basically what that does, it will create the memory on the stack rather than the heap. And so you may run out of memory, or your memory may be removed when you actually go back to another function. Okay, so please don't do it that way. Whenever we've got dynamic memory, we should be using malloc unless you know what you're doing and it's safe. All right. So basically what we want to do is we want to create a two-dimensional array. Now, we've already seen in the first assignment how to create a one-dimensional array using malloc. First, we need a pointer, and then we can just malloc size of the type, and the type will always be one less star than is here. Okay, and then we times however long we want it. So if I wanted, let's say, 3 ints, there'd be a 3 there. In the first assignment, you had n plus 1, okay, and that created n plus 1 ints, and a would point at it. So it had a, and that point at a bunch of ints, noting that that's a pointer, and these are just ints. All right. Now, if we wanted to create a two-dimensional array, there's actually a number of ways we can do this. And we're going to do probably the easiest way to do this dynamically. There are some more difficult methods, but we won't cover them here. And you'll see them next week in the lab, where you only have one pointer, but we'll have lots of pointers. All right, so if I wanted to create a two-dimensional array of ints, I want something that looks like this, okay? So that I can put stuff in different places. And most of you will know this as something in mathematics as a matrix. Basically, that's what we're creating. The difference in programming with our two-dimensional arrays and matrices is that we can end up with things like this, and that's perfectly legal, okay? So just keep that in mind. We're not going to do that here, but let's have a look at creating a two-dimensional dynamically allocated array for ints. Okay, so I'm going to do ints. Okay, now remember in the lab that I said wherever you see int, you should be able to replace it with struct something. Okay, so keep that in mind. All right. So if I need a two-dimensional dynamically allocated array, basically I need a double pointer. Okay. So there is two different ways you can do this, and it's completely up to you. Personally, I would go follow these steps. Okay. So I've done it per row. You could do per column. All it changes, okay, is the order of these. Okay, so I'll show you what I mean. Okay, and then we'll have a look what it means, because there is two ways to do this. All right, so I've got a double pointer. I'm going to call it A. Okay, and for A, that's an int star star. Now this has to point at a int star. Okay, so we're going to create an array of int stars. Now, as I said before, the size of always needs to be one less star. Okay, so size of int star times however many we want. Now, these are going to be our row pointers. Okay, so basically we've said here for each row in the each row in the image. Okay, so we've got our width, okay, which will give our rows. Okay, so we've said this has a height. Did I make a mistake? No, that's right. So I've got a height of 3. Okay, so that should be how many rows we want. We've got 3 and 3. Maybe I'll change this to the same example. We'll go 3 and 4. Sorry about that. All right. So our rows are going to be the height. Okay, so this is our image. We've got a height of 3 and a width of 4. Okay, so we've got 4 by 3, and that's our image. Okay, it's a pretty boring image. Okay, let's say it's just some checkerboard. All right. So how many rows do we have? We have 3. So in here, for my int array, I'm just going to write the number 3. However, for you, you can get that value from here. Okay, so we can do that in a sec. All right. So I've now got 3 new variables. All right, 1, 2, 3. Okay, and they're all int stars. Okay, so they're all pointers. Okay, so I created 3 size of ints. So I've got 3 size of ints, and malloc returns the address of these. So now it points at those 3. Okay, does that make sense? All right, just this part. Does that make sense? This is nothing new compared to assignment 2. Okay, all we're doing here is creating 3 ints. The hard part is the next part. So what I'm going to do is I'm going to redraw this. Now, this is not how we'd normally draw a box and pointer diagram, but I'm drawing it just so that it looks a bit more like the image. Okay, because it'll probably help with understanding. So we've got 3 pointers, okay, and they're going to point somewhere. So what I want to do now is basically have a pointer to however many columns there are. Okay, so that'd be 4, and then I'm going to do the same thing for this one, and I'm going to do the same thing for this one. Okay, so that's what I want. All right, now if we have a look at what I want, you'll note that I'm creating dynamic memory once, then I'm creating dynamic memory again, and then I'm creating dynamic memory again. So I'm repeating something. So it means that I'll need a loop. Okay, so we'll definitely need a loop, and we know how many times this loop executes. It's whatever number is here. So I'm going to use a for loop, but I'm going to run out of room. Maybe I'll do it underneath. So let's say we've got an I is 0, I less than 3. Okay, obviously this will be different values. Okay, this is just for the int example. All right. And then in here, we can dynamically allocate each one of these. Now, if you liked, you could use pointer arithmetic on this, okay, to get each one of these. Or you can just use array notation. Okay, so we've got the variable a, okay, and a0, okay, is this. Okay, keep in mind that when I say a0, all I'm talking about here is star a plus 0. Okay, it's the exact same thing as dereferencing. It's just a shorthand way of writing it. Okay, so feel free to use array notation. Even though these are pointers, we still can use array notation. Remember, this is an array. Okay, so if I want to refer to this first one, I could say A0. Okay, but I don't just want to set the zeroth index. I want to set each of these. So I want to say AI. Then I'm going to call my malloc. Now, AI, okay, for each one of these are all int stars. Yeah, that's what we're doing. That's what we're doing. I'm just trying not to give all the answers away. That's exactly what we're doing. Oh, okay. Yeah. So, oh, okay. Yes, you could do the width. Oh no 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 no. Oh no no. I see what you mean. Okay. So you could do the width instead of the height. It will just change the way you do it. The reason if you do the width instead, all you'll get is this 4. Okay. You still won't get the other ones. Now, there is another way you could do it where you do a multiplication, but your maths will start getting very complex. So you could do a malloc for the whole file, but it gets complex. And you'll see how that's done next week in the lab, but you won't be doing it yourself. All right. Let's keep going. So, what I'll do is I'll do the width next, okay? And we'll have a look at the width instead. We'll do it both ways. All right. So what I'm going to put here is int star, okay? And now in this malloc, I'm going to get the size of an int, okay? So I get the size of an int because I want to create 4 ints for every row, okay? Because the image has 4 pixels. Well, here we're saying ints. It has 4 ints per row, okay? And then we'll times that by 4 because that's how many there are. So now we go around this loop. So when I equals 0, we create 4 ints, and it returns a pointer to A0. So now this is going to point to the newly created ints. Okay, so now we've got 1 int, 2 ints, 3 ints, 4 ints. Then we go back through the loop, and we do the same thing again. And now we get the next set. And then we do this again, and we get the next set. Okay, and now if we have a look at that, okay, we've got 4, 8, 12 ints. Okay, and if you have a look at the little image we've got, we had 12 ints here. Okay, so that's how we create it. Now, obviously, you're not using ints. You're going to be using struct pixels, and we'll have a look at that in a sec. Now, someone asked, why don't we do it by height? We could do that as well. Let me just show you. If I wanted to access this specific pixel in my image, okay, then what I need to do is I need to write A. I need to refer to which row I want. So it'd be A0. And then I need to refer to which column. So that'd be 1. And that'd get me this specific pixel. Okay, and you can see us doing that later on. Okay, and so this here is our rows, and this here is our columns. And this will give us which one we want. Okay, now if you do it the opposite way, okay, so the opposite way would be to use columns. This isn't the way that's suggested, but someone has asked about it. Basically, instead, you would create 4 pointers. Okay. Okay. And this would change 4, and this would change to 3. Okay. And then you'd have each one of these would need 3, and our image is sideways, but that's okay. Okay. So if you went with columns instead, you still need to create each of the individual parts. Okay. And the other difference is that these would be in the opposite way around. So if I wanted, now remember this is sideways. Okay. So if I wanted, for example, um, this pixel, which, so we're going width. So that'd be the first one and the third one. So it'd be that one. So now we would go A0, 2. Okay, where this is our column and this is our row. Okay, but okay, so you can do it the other way. Okay, it's just a bit easier doing the rows first. And yeah, it's up to you. Either way will work. However, everything I give you, you just have to reverse. All right, so we know how to do this now. The only difference is, and some people get confused by this. No, we only do this once. Okay, this is storing our image. We definitely can't do this to invert the image because this is getting the image. So it doesn't have anything to do with inverting the image. And inverting the image is inverting the colors. So no, you can't create memory to change the image. All right, so let's have a look at the first malloc that we need to do. So for ours, oops, and then you can do the one that's in the for loop. All right, so where we want to actually store this original pointer is going to be here. Okay, so instead of it being pixels or something like that, we need to dereference it first from here because we don't actually have direct access to this. So we're going to have something like image underscore pointer. Then we can use the arrow to dereference it, and that'll give us our pixels. Okay. And then we're going to use malloc on that. Now, the type of this is struct pixel star star. So we're going to have struct pixel star star. Whoa, we're going to end up in other territory. I'm just going to delete that. We're going to have malloc. Then we're going to have size of Go away. Size of struct pixel. Now remember, these are our row pointers. So they are pointers. And as I said before, the size of should always be one less unless you're doing something a little bit more advanced. Okay. And then we need to times it by our height. Now we don't have direct access to our height, so we need to go through this image pointer again. And I'm just going to put it in brackets because I don't like putting stars before this. Okay, so I've got size of struct pixel, and that was height. Okay. So that'd be our first pointer, okay, and that would give us our rows. Okay, so this is changing it from ints. So that would give this those rows we saw before. Okay, then we would use our for loop to do the rest. Now, we can still do our array notation. Okay, so we can write image pixels I here. Okay, and then you can the stuff that goes here. Okay, which would be the malloc, etc. that I mentioned before, except for it wouldn't be ints. It's going to be struct pixels, or struct pixel, sorry. All right. All right. I'm just going to have a 2-minute break. Let me know that that makes sense. Okay. I'm not going to give you what's in here, but that should be heaps and heaps and heaps of information. So let me just have a quick 2-minute break and I'll be right back. unmuted. Sure. Cool. All right. Is everyone still there? Can something just say that you're there? Did everyone run off? A quick break too. I'm there. Cool. Cool. All right. Made it in Teams. Ah, I think you meant time. All right. All right. So now we've got through that. There is a diagram there to help you. There's not going to be something this complex on the exam. There will be malloc on the exam, but this isn't an assignment. It is meant to be a little bit more difficult. As I've said, the assignments are where we really want to test your knowledge and test your problem solving as it's more realistic. So the exam won't have something this big in it. It definitely will have malloc though. Definitely. Okay. But I can't imagine it'd be too hard anyways. All right. Now, we haven't done two-dimensional arrays at all, so we shouldn't have ever really seen J. Okay, and I've told a lot of people off about this. J should only be really used when we're got a for loop inside of a for loop. Now, in this assignment, a big hint that for every single one of your operations, so you've got removing a channel, you'll need this for loop within a for loop. You'll need it for the inverting image colors. You'll need it for the quantize, and you'll definitely need it for the horizontal. So you're going to be doing this part a lot, and this will definitely help you with the inverting, as someone asked before. So we're going to create two iteration variables, just int I and j. Okay, that shouldn't be anything too extreme. And we're going to create some for loops. Okay. Now we've got a for loop within a for loop. You'll see this often when dealing with two-dimensional arrays. If you're using three-dimensional, you'll see 3 for loops. The reason for this is basically one for loop is for going through each of the rows, where the other for loop is for going through each of the columns. So if we want to look at every single something in a two-dimensional array or a matrix, we can. Okay, and it'll allow us to iterate through a two-dimensional thing. So whenever we've got a one-dimensional thing, we only need a one for loop, and that'll take us from the start to the end. Okay, but if we need to iterate through a two-dimensional array, we need 2 for loops. And if we needed to get through a three-dimensional array, we'd need 3 for loops. And if we had a four-dimensional array, we had multiple three-dimensional arrays, then we'd need 4 for loops. Okay, so that's basically the way things go. So to do this, we're just going to use our for loops like we have before. We're going to start at 0. We're going to go to a particular point. Now, here is going to be our height. Okay, so less than image pointer height, where this one's going to be our width. Okay, so basically here, our I is always talking about our rows. Okay, and a J is always talking about our columns. Okay, and this is important. Okay, so if you want to double check something, a particular row, you're always referring to your I, where if you're going the other way, if you're going through the columns, you want to be looking at J. Okay, you can flip these around if you like, and you can go through the columns one at a time. So if you wanted to do the columns first and then the um, the rows, you just flip the for loops around. So currently, the way that it'll iterate, because I'm doing the rows here, okay, basically what will happen is it's going to iterate this way. Okay, if I put the columns first, it's going to go this way. Okay, and if you did do this backwards, then these would mean different things. Okay. All right. Now, we are going to use fread. All right. So we're going to read from our file. Okay. So for every single pixel, it will have 3 bytes. Okay. Now, don't get confused by this. It's not a mistake. Okay. The order that RGB images are stored in bitmaps is blue, then green, then red. Okay? They are backwards. Okay? And you may know the reason why already from what we've talked about in other labs. Okay? So make sure you're aware of that. Okay? It does go blue first. If you do it backwards, it will still work. Okay? You will still be able to save the image, but you'll notice that your colors are all screwed up. Okay? Except for the green. The green will be good. Okay, and have a play with it if you like, because you can do some interesting things just by reading the data incorrectly. All right, so we've got this here. Okay, so this here, we've got read the next byte. Now, if we're going to read a byte, what function should we use? Put it in the chat. Byte, 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 byte. Okay, so we're going to use fread. Okay, so we're going to use, yeah, we're not doing Java. We're going to use fread. Okay. 3 times, 1 for each color. I've told you where one's going to be stored and shown you an example. This will help you out a lot with these problems because this basically gives you a particular position. So we've got at image pointer pixel I j dot blue. Okay. And then we've got whatever comes after that. Then we've got another argument, whatever comes after that, and then another argument, whatever comes after that. I'll let you work that one out. You should know what goes there by now. Yeah. And then you're going to do the same for green and red. Now, where's the dot? let's have a look what this I and J are doing, just so that you can understand what's happening. So I might just draw another array here. Okay. So we've got 0, 1, 2 there. We've got 0, 1, 2, 3 here. Okay. Now, I'm drawing it like this. I'm not drawing it using, I don't even know where those pictures went, box and pointer diagrams, because it gets ugly. Okay. And each one of these will have 3 components. So it's going to have a red, blue, and green component. Okay. Now you can draw this however you like if you need to draw something to test. But I'm just breaking the boxes up into 3. Okay. This isn't a standard diagram. It's just to help me understand where things are getting stored. So basically, when we start this for loop, we've got I is 0. Okay. And we've got J is also 0. So I is 0, goes into here, and then J is 0. And we get to here. Okay. So remembering what we put up here before, I probably got rid of it. I did get rid of it. So this first bracket is our rows, and our second bracket is our columns. Okay. So what I'm saying here is that row 0, column 0 dot blue, let's say this top left-hand spot is our blue. That color will go there. It'll be a number. Okay. Then we'll get the green. Okay. And then we'll get the red. All right. Then we come back up in our for loop and we'll increment. Okay. Our J. So J will now be 1. So now we're talking about row 0, column 1. So we're looking at this pixel here. Okay, so what we're doing now is putting the blue, red, and green in here. And then we increment J again, we get 2. Come back up, we fill that in. Then increment J again to 3. We come back up, J gets incremented to 4. 4 is not less than, yeah, 4 is greater than the width. And so it's not going to continue. Not 4 is equal, so it's not going to continue. Sorry, right? Because this would be less than, greater than J. Sorry. All right. So we've got 4 on this side, 4 on this side, so it's not going to work. And so we go back up, and I gets incremented to 1. So now we've got row 1, column 0, and so on. And we fill the whole thing up with all of our values. Okay, so we should end up with a whole image. Okay, after doing this step. All right. Then we need to close the file. We know what function to close the file. And then we print something to the screen, which is image loaded. And then 2 new line characters. Okay, and then return 0. Now return 0 just says that we're successfully finished. Okay, this function isn't inside main, so the function calling it will use these values, either the 0 or the 1 somewhere, 1. Okay, so that's loading the image. Now, once you've got that, we really need to test this. And so we have our save copy function, which will call this function. Every operation will load a new image. Okay, so this is important. We don't just load one image and apply stuff to it. Every time we call one of these, it'll load an image and then save it. So we've done all that. We'll come back to save. Okay. And we'll look at save image copy first. Okay, so this image here doesn't accept any arguments, and it also doesn't return anything. Okay, so we're going to create a struct RGB image. Now that would be this one here. Okay, this is the one that when we're inside of the load image function was pointing to. Okay, so this is the one that would be in another function, okay, that we talked about before. We then call the load image function, okay, and you need to store what's returned. Okay, so we know that our load image returns an int. So if it returns an int, okay, we're allowed to write something like this. Okay, and something goes in here. Okay, so this might be something about the validity of loading this image. So you might want to call it valid or something. I'd probably actually call it invalid, because if this fails, what value does it return? If it can't load an image, what value does this load image function return? Losing people. So it returns a 1, and we know that because we did that earlier. Okay, so we return a 1 from this load image function. So if it's successful, we return a 0. Okay, so this variable, whatever you want to call it, I've called it invalid, would be 0 if this worked, and 1 if it failed. And this is handy because, well, I can't really save an image if I can't load it. So this will tell me if I can. So I've got a question here: if the image was loaded successfully. Okay, so we can use an if statement and check. Okay, so if it was successful, then we're going to do add the text copy to the file name from image using string cat. Now, you don't really need to create a copy here because we're going to get rid of our image anyway. But if you want, you can create a copy. Basically, if you've got hello.bitmap and the output file name should be hello underscore copy.bitmap. Okay, so you're going to add the text underscore copy using the string cat function. Okay, you've got your struct. Okay, so you can access that file name, remembering here that it's not a pointer. So if I need to access it, I just use the dot. Okay. Sense? All right. Then print image copied in 2 new lines. I think everyone can do that. Then you're going to call the save image function and pass the appropriate argument. So we'll go have a look at that function in a second. Okay. Now this does return something, but we're not going to bother storing it. What you're demonstrating here is that you understand that some functions can return stuff and that we can save that value, or we can completely ignore that value that's returned. And we've done this hundreds of times already because printf actually returns a value and we haven't stored that at all. Okay, so some functions we just ignore what is returned. Then we're going to free the dynamic memory. Okay, so we need 2 more functions to finish this off. But as I said before, these, if you call them, will just print out not yet implemented. Okay. Make sure this all works before trying to do any of the remove image or invert or any of that stuff. So we need to go do the save next, and then we'll do the free last. All right, so we'll go to the save. All right, so now we're looking at the save. Now, once you've done the read, not the read, the load, the save is not too difficult. So create a name of the file name from image and store appropriately using string copy. We've already done that in the load. The only difference is this assignment supposed to be more difficult? What do you mean more difficult? This assignment's, once you get through the load, it's actually pretty easy because all the functions are very short, small. Last year and the year before, the second assignment, they used to have to do this, but we got rid of that and put it in the third assignment. So people in the past have done it, so you can do it too. And they did it earlier. All right. So string copy, we've done that. Add an extension, we've done that. Just keeping in mind that we're not using a pointer here. Create a new file. Okay, so remember with fopen, okay, we've got different modes. Okay, we've got reading, we've got writing, etc. Okay, so you need to work out what's the most appropriate here to create a file and write to it. Okay, you've also got appending and a bunch of other ones. They're all in the lecture notes. All right. Now, when creating a new file, it's very, very unlikely that the file won't open. Okay, but it may not open. Maybe you don't have enough memory to create a new file. So you should always check that it could actually be saved. Pointer or a variable for a struct. Well, it depends what variable you have. So here, this isn't a pointer. This is the actual struct that we're passing. So we're actually getting a whole copy of the struct. Where here, you've got a pointer. So it depends what was passed. Okay, so we've got a star there. Now, for design, if that's what you're asking, basically you need to work out what's efficient and also where you're going to need that memory later. And do you want to change the original or not? Well, it's given to you. So you don't need to work out where's most appropriate. With single arrays, you are meant to work out where's appropriate. So, for example, we've seen in the labs when we did functions, if we want to pass values back to a function, we need to pass a pointer. But if we just want to access the values from it, then we don't pass a pointer. Okay, so with the save image, we're saving the image, so we don't need to give any information back because once we're done with it, it's done. However, with the load, we want to actually get that information back to us, and so we pass a pointer. Okay, so remember that when we pass by a pointer, we're passing by reference, and it allows us to return more than one thing. So here, it's appropriate to pass a pointer because we actually want to pass that information back to the calling function. Does that make sense? So remember, very early on, we had, I think it was int add, I can't remember what it was. Let's just say func, okay? And we had 2 pointers here because we wanted to change the value of A and B when we got back to the function. If we just passed these in, then it wouldn't change them when we got back. And so if we didn't pass a pointer into the load function, we wouldn't have the image name when we returned. We wouldn't have the whole image, and we wouldn't have the height, width, and size. For the save function, we don't need anything back, so we can just give the information. Okay. With double pointers, it gets a little bit more difficult. And that's usually if you're passing a two-dimensional array or you're allocating the memory in the function itself and then passing that pointer back. But we've only done that once in this subject, so we're not expecting you to do that. But if you are designing something for yourself, that's the reason we do it. All right, let's keep going. Insert the following code below your code from step 3. Okay. I don't think you should have any difficulty with basically rewriting code. So here, what we're actually doing, okay, is inserting the header. Okay. So before, what we were reading when we were reading all this data about the size and the height, the width and the size, that was in the header. Now, what you'll notice is these first 2 bytes here are the 2 bytes we skipped. They're constants, so we just write them in. After that, we got the image size. Okay. Then we skipped a bunch of bytes. So we skipped 12. Okay. They're constants, so we just put them in. We then write our width and height because that's what followed. Then we skip the next 28, but we're inserting something here. Okay. Size. Did I forget something? Let me just check something. Oh, yeah, we got the size. Wait. Ah, the size is here. That's all good. Sorry. Yeah, that's correct. Cool. Then we get the size and put it here. Okay. And then we skip the rest. Why is the... Ah, I see. Sorry. Then we write all that data as our header. All right. Then we're going to do the opposite of what we did before. So we're not going to read the data. We're actually going to write the data. So we're going to create some iteration variables. We're going to create 2 for loops. And we're going to use fwrite this time using this. Okay. So I've given you exactly what's going to be written. So this shouldn't be too hard. Okay. and we've got blue, green, and red. Once again, they are backwards. Okay, and we close the file and print image saved. Okay, so that the save image, there's not much difficult in there. Once you've done the load, it's pretty much I give you all this, and you do exactly the same thing except for right, and you do exactly the same thing up here. All right, so we've got one more function that we need, and that's the free. Now, a lot of people stuff this up. It's not that hard, but I do want to go through it with you. So let's go back to our int example. Okay, so malloc. I'm not going to put the typecast there. As I said, the typecast isn't necessary, but it helps a lot of people understand what is returned. So I'm just creating a two-dimensional array of ints. Okay. So for our ints, gotta have more space. We've got a double pointer, okay, and that points at 3 single pointers, okay, and each one of these points to 4 actual ints. Okay, so that's our mallocing. We did that before. Okay, so what we've got to remember is that what's a good color? All of this pink section here was dynamically allocated, and so was all of these. Okay, the only thing that wasn't dynamically allocated is the original pointer. Okay, so if I go now in my free function and I write free a, okay, the problem with this is that it's going to free all this, okay, but now I have no clue where these 3 are. Okay, I have no clue where these are because I don't have pointers to them anymore because I freed this memory already. So this has to always be the last step. Okay, I need to free all 3 of these, or however many there are, before I free these. Okay, so whatever this points to. So we can't do that yet. So we basically are going to go backwards. Okay, so we're going to free this one first, then this one, then this one, or this one, this one, this one, any order, it doesn't really matter. But we need to free all of these before we free this. So the first thing we're going to do is create a for loop. Okay, and we're going to go around 3 times here. Now, obviously, yours isn't going to be 3. And we're going to free each one of these. So I'm going to free a I. Okay. And once I've freed those, then I can free a. Okay. Because this will go through. It'll free this one. No, it'll actually free the first one. I'm not doing it completely backwards. You could do it backwards if you wanted. I free that one. I free that one. I free that one. And then once I've done that, I free this one. Okay. And then all the memory is freed. Okay. So make sure you do this one last. Okay, so with our free function, wherever it went, okay, so free all the rows first, and then all the pointers to the rows. Okay, you've got a struct RGB image that has the pixels in it. Okay, so remember you've got pixels. Okay, and that's a pointer. Okay, so you can use that and that there and that here. Does that make sense? Once you've done that, should be able to use menu option 1 and save an image. And that point there, you've pretty much got everything you need. Now, don't start doing the next sections until you do get that working, because without that working, you're just going to be guessing. The great thing about this assignment is that basically once you get that working, you've got images that you can actually test on to see if it works. So you can try it. Oh, it accidentally got rid of all the green rather than all the red. You can quickly fix that up. But if you don't have any images to look at, you won't be able to find out if it's working or not. So just let me know if that's all making sense. I don't think there's much more to go through. Everything else is pretty much the same thing. All right, just let me know if you're still here, and we'll quickly go through one other function, and then any other questions you have. All right. So if we have a look at the so once we've got that working, we should get an image out. I just want to check something. All right. So once we've got that, we should get an image out. Now I did say that I'd show you what the data looks like. Well, let me just see if I've got a hex editor. Oh, there it is. So just show you so that you can have a look. So that'll do. Yes, yes, yes. Okay. So I'm going to open up one of these images. Okay, and I'm going to use a program called HXD. Now, this is a really handy program um, if you're dealing with um, binary data, okay, where basically you don't have ASCII characters and stuff. And you can have a look through this and you can see that all this information at the top is your header information. And you can use this program to check your header and see if it matches and see if you're reading it correctly and see if you're writing it correctly, etc. And then what follows is all of the image data. Um, okay, and so you can see the red, blue, and green components. So you can try this with like a really small image and you can test this for yourself. Just making sure that you keep those constraints in mind. Okay, so it's just called HXD and you can download it on the internet and it's free. Okay, and it's a fairly handy bit of software to actually see what values they are. Now, these are all hexadecimal. Okay, you have to be used to hexadecimal, but it will show you what's in memory in a particular program file. Okay, but that's just one thing I thought I'd show you because it is handy, especially when dealing with files like this that don't have just text. Because text's easy for us because we can just read it, but when we can't, some other programs can help. All right, so once we've done that, we should set up. We can start looking at the remove image channel. You'll notice that it's pretty much the same as the copy for the first couple of steps. So you've got create an image, load the image, and then if it was loaded, exactly the same as our copy, then you're going to create a menu. I don't think you'll have problems creating a menu if you could create the original menu. Um, if the user selects a valid entry, then it should do these things. Okay. Once again, here, if they don't, just repeat. Um, there's no prompt. Okay. So in this one, we're not caring about telling the user that they've said something invalid because we're not marking that and we don't really care for this assignment and we don't want to waste time with little things like that. From there, we're going to call a bunch of functions. I've told you exactly how to call it, so that makes it really easy. And we've got one for each remove red pixels, green pixels, blue pixels. The functions are pretty much the same, except for pretty much one word, even inside them. And then you're going to append. You've done that already. You're going to print something to the screen. You're going to save the image and then you're going to free the memory. Okay, so you can see that these functions are very, very similar. So once you've done it once, it shouldn't be hard to replicate. Now, if we actually go to the functions, they're fairly small. Okay, you'll notice that we're using our iteration variables. Okay, so we've got I and J. Okay, so once again, wherever you see I and J, you know that you're going to need two for loops within each other. And the reason for that is that if we've got our image, okay, I've got a 3x3 image. Remember, they have three colors. Okay, we've got R, G, and B. Okay, and these all have values inside them. Okay, so they might 8, 4, 12, 72, 6, whatever. Okay, so these all have a bunch of different values in them. And basically what we're doing here is we're going to iterate. So we're going to go to each of these locations. And all we're going to do is all the red ones, we're just going to set them to 0. We're just going to go through and set each one of those to 0. Okay, so you're going to use your struct again. And remembering this time you're not sending the whole image struct, you're just sending a pointer pixels. So because you've got a pointer to the row of pixels, which will point to all of the columns. So basically here, if I wanted to access, let's say this very middle one, and I was inside this function, because I've got pixels, now it's not a pointer to a double pointer, it is a double pointer. So it's exactly what we have before. So I can just use these square brackets, okay? And I want row 1, remembering it starts at 0, and column 1. And I could say dot red is 0. Okay, notice that I don't need anything beforehand because I'm not dealing with the struct image anymore. No, it doesn't make it white. Okay, so you need to be careful about that. It'll actually make it darker. So when you have full color of all the pixels, then it will make it white. And if you have no color for all of your pixels, it will make it black. But maybe I can show you on here. Yeah, I can. All right, so let me show you an example. I need an image. Actually, I can just grab one of the images. That's probably even easier. And open there. Cool. So let's have a look at some of the examples. So on LMS, there's an input file, and it also has examples of the outputs, so you can see what it's expected to do. But let's have a quick look at some of them. No, assignment 3. Okay. So here we've got an image. Okay. We've got blue, green, red, and we've got some colors in between. If I remove the blue channel, okay, you'll notice that all the blue's gone, okay? And you'll notice in this, like, acry, I wonder if I can zoom. Yeah. No. Zoom. Zoom. Cool. Oh, don't do that to me. All right. You'll notice in this acry color, and you'll also notice in the blue that blue has actually a bit of green in it. So you can see, you may be able to see that it's still a little bit green, okay? Because whilst it's got rid of the blue, it hasn't got rid of any of the green in those pixels. And if you have a look at this S, okay, this S is a little bit greeny. And so now that the blue's gone, it's completely green. Okay. So if I got I don't have a full image. So basically, removing a channel will do that. If I remove the green channel, it will look something like that. Okay, and if you remove all 3 of the channels, you will end up with a black image, not a white image. White would be all of them full, so setting all of the colors to 255. Okay, and you can play around with that if you like. So instead of removing, maybe you just set it to full and see what happens. Because you can do some really cool stuff here. Okay. Someone asked about inverted. Okay. So inverted would look like this. Okay. And basically this changes the values in terms of their binary data. And we can have a look at that very shortly. Okay. Yeah. But all of that is inside of the folder that's on LMS. So you can have a look at the outputs and they've got the right names and everything like that. I might actually move them to separate folders so that you know what's an input and what's an output. Okay, so that's removing the red pixels. And yes, it will make it slightly darker. I didn't copy the rest in. So let me just talk quickly about inverting. I can't remember how much information I gave you about inverting. Let me have a look. Oh, I already told you. All right. So inverting, basically just use XOR. Okay. So you've already seen the XOR operator. And so where are we? I lost the assignment sheet. So you've seen this operator. Okay. So let's have a look at something. Why is that? When do we use XOR? It was a very early lab. It was lab. It might have been lab 4, I think. No, it's before that. Might have been lab 3. Have a look. Yeah, it was lab 3 that we used XOR. So XOR is the little caret symbol. Okay? And that's our exclusive OR. So basically, we had our OR where either of them could be true or both could be true, where XOR is basically only one of them will be true. So I'll show you how that works. Yeah, BitLock. So if I had, let's say, I'm going to use a car because it's nice and small, and I set this to 0B 1 0 1 1 0 1 1 0. Okay, and then I went A becomes A XORed with 0B 1 1 1 1 1 1 1 1. Okay. So now we're going to do some bitwise arithmetic. So we're going to get A. I'm going to go 1 0 1 1 0 1 1 0. I'm going to go 1 1 1 1 1 1 1 1. Okay, remembering that this is XOR, not OR. So we've got XOR, OR, and we've got AND. Okay, so AND is a 1 if they're both ones, OR is a 1 if they're either of them are a 1 or both are ones, and XOR is if one of them's a 1. So if we have a look at this least significant bit, 0 XOR 1 is a 1 because one of them is a 1, but not both of them. If we have a look at this next set, both are a 1, so that would be a 0. Both of them are a 1, so that'd be a 0. One of them's a 1, so it's a 1. Both of them are 1, so it's a 0. Both of them are 1, so it's a 0. One of them's a 1, so it's a 1. And both of them are 0, so it's a 0. And if we have a look at that value, okay, and put it beside our original value, we've got 0, 1, 0, 0, 1, 0, 0, 1. So it's inverted the binary values. Okay, so we can use this to invert our colors. All right. Is that all good? Is there any other questions? Are we happy? Are we sad? Or are we all good? Hopefully that was helpful. Um, there's not as much to explain. There's not much math in this assignment, um, and it's fairly repetitive. So you get good practice using um, arrays and pointers. That's the purpose of this assignment. It's just a bit of repetition. So the quantize is using bitwise operators, but a little bit more difficult. And there is a number of ways you can do it. So you just need to have a play around with all your bitwise operators. So remember, you've got where's my pen gone? I just dropped it somewhere. Sorry, I was on the phone playing with my mobile. Right, so remember that you've got a bunch of bitwise operators. So you've got shifting, okay? You've got knots, okay? So there's a bitwise knot, okay? You've got ands, you've got ors, and you've got bitwise ors. So using those, can you work out how to quantize? And the flipping, what I recommend you do is have a look at um, the function where we sorted an array. We use bubble sort. So there, we actually move things around in an array. Okay. So because we were sorting, we were moving things around. So that might be helpful in the way that we stored something, then moved something, and then moved the other one somewhere. Okay, so that's for the horizontal flip. Um, Having a look at the bubble sort algorithm, just the storage part and how we swap something may come in handy. But the iteration is pretty much the same. The flip might be slightly different in terms of how you do it, but it's always going to be 2 for loops. Unfortunately, we can't do 3D images. Yeah. Flip image and flip pixels. Where's it say? Ah, okay. Um, you're talking about here. Um, so the flip horizontal image is the menu. Okay, so that's basically like the save, not save. The save image copy is the menu where it creates the image, it loads the image, it does all the adds the end bit, and it calls the appropriate functions. Same with this next remove image channel. It prints all this stuff and then calls the function that actually does the task. So this flip horizontal image is the one that loads the image and then adds to the end of the file that it's flipped and then saves the image, where this invert pixels is the one that actually inverts everything. Okay, so these 5 are the functions that load the image and save the image and call the appropriate function that does the task, where these functions here are the ones that actually do the task. Does that make sense? So these 5 are very similar, and these 6 are sort of similar. All right, awesome. I don't think there's anything else. You got any more questions? When's the assignment due? Next Sunday. So if you accept the submission agreement, it shows up the date and time. It won't show you unless you've done that. So if you just do that, let me get it up. Oh, okay. Which bits should we do first and last? This one's designed a little bit more um, so that you can do certain parts. So um, so this one, yeah, once you've done the loading and saving, um, you could just do all 5 of these if you like, because they're very, very similar, and then go off and finish these off. Um, so definitely the menu first. You might skip the loading and saving and do this function first, because then you can test if it works. It won't actually load an image at that point or save an image, but it will run. Then I'd go back and do the loading, saving, and freeing. And then once you got that, it's really up to you which order you want to do the particular operations on, because they're all similar difficulty. The flip horizontal is probably a little bit harder than the other ones, but oops, why did I do that? But it's up to you. Why? There we go. This the because what you got to consider is that the removing the red pixels is not dependent on the quantizing, and inverting is not dependent on removing the red pixels, etc. So you have no dependency, but you have a dependency on the save and load, pretty much the whole thing, and the menu, um, everything's dependent on as well. So basically, just work out what's dependent on what, and always do the thing that's required first. Just, no, now I've lost the chat. There it is. How do we create the menu using Switch? If you want to use Switch, you can. Um, that's up to you. Um, but at the start, I showed you with if, else if. Um, it's very similar using Switch. And you just replace the if, else if statements with Switch. And reiterating, as we said at the start, using a do while loop. There is no bonus. There is no bonus in this assignment. Yeah, we. I didn't get time to do a bonus, so I just didn't include a bonus. Um, they're not part of the assignment, so they're not really necessary. In this assignment, the marks are a bit more lenient, so I just didn't do one. If you want some bonus tasks, I can do one, but they won't be for marks. Because I have got the bonus written up, but it's a little bit difficult, and I prefer you focus on the task. All right. I think everyone's kind of got their answers, so we might leave it there. Um, yeah. All right. Thank you very much for your time, and hope that was helpful. Also, one other thing, don't forget to leave the feedback for the subject before. Hopefully, it's already done tomorrow. Um, so you would have got the SFS survey. Please, please, please fill it out. Um, helps me do stuff like this. All right. Thank you very much.